All right, let's look at number 1 from this the reducing radicals worksheet here. So there's a number of ways that you can do these problems, okay? And one, my favorite way is to use what I called in the video lesson the radical reducing machine, which is this little process here that you can see over number 3. There are other ways to do it. One of them is described up here in looking for perfect squares. But I like my way because you do enough of these. This, I think, ends up being the fastest way. So what you do is you take the root, whatever's under the root, the radicand, I guess, technically. You put that number in this little half box here, and then you ask yourself, what is the smallest prime number, or what is a small prime number that goes into 12? And, you know, those are numbers like 2, 3, 5, 7, something like that. So I'm going to take a 2 out. Okay, so 12 divided by 2. So then I take 12 divided by 2, and I get 6. Then you ask yourself again, what's a small prime number that goes into 6? How about 2? 6 divided by 2 is 3. What's a small prime number that goes into 3? Well, that's just 3. 3 divided by 3 is 1. When you get to 1, you're done. Now, what I'm going to say over and over as I do these and I help students in class is, sorry, I should have written this better. But anyway, so square root of 12 is going to be equal to. What I've done here is I've completely factored this. And what I'm going to be telling students in class, and frequently, is you're going to circle pairs of numbers. And I'm going to show you why on this problem I would circle pairs of numbers. Because what I've done over here is I've completely factored 12. I've got 2 times 2 times 3. That's the complete factorization of it. 2 times 2 is a perfect square. It's a perfect square because that's literally what we mean by squared, is the thing times itself. So that would be 4 times 3. All right. I can break that into the square root of 4 times the square root of 3. Square root of 4 is just 2. Square root of 3 doesn't simplify anymore, so that's it. That's my final reduced version of the square root of 12. Now, when I show students this, and on future examples and stuff, I'm not going to show all of that out. I'm just going to say, look, there's a pair of 2's right here. That means it's a perfect square, so you can take that pair of 2's and put it right out in front. And then you take whatever's left over. Those would be the not perfect squares that are, you know, the factors that are not perfect squares that don't result in perfect squares, and those go underneath the root. Okay. So it'd be worth doing number 2 to look at as well. So real quick, let's take 27, put it in the little box. Small prime number that goes into 27, how about 3? 27 divided by 3 is 9. Take a 3 out of 9 again, I get 3. Take a 3 out of 3, I get 1. When you hit 1, you're done. Circle pairs of numbers. So with this method, we can just jump right to, hey, there's one pair of 3's that comes out in front of the square root. Whatever's left over goes underneath, so 3 would go underneath. All right, and there's your final answer, 3 root 3.